In this video, try to work out the probability of getting a double with 3 dice. So, for example, you could roll 3 dice and you could get, let's say, a 2, a 4, and a 2. So this is a good outcome because you've got a double here. If you get a 3, 3, and a 1, this is a good outcome because you've got a double here. 2, 5, and let's say a 4 here. This is a bad outcome. There's no double here. You could argue that 3, 3, 3 is a double, but for our situation, for argument's sake, let's just define this as not a double. So you could argue, yes, it is a double, but for what we're doing, let's say this is not a double, okay? A double has to be exactly a double. So this would be a bad outcome. Getting a 6, 6, 6 would be a bad outcome, okay? Just for argument's sake. So for what we're doing, this is classed as not a double. So try and figure out the probability of getting a double with 3 dice. Again, with probability, you've got to try and draw a map of all the things that could happen. So rolling 3 dice, you could imagine as rolling one die, and then once you've got the outcome, then roll this die. So you have 6 more, and here you have 6 more, and so on. And then this column here will represent the second die, and then it will jump. Well, another 6 jumping out. So this, and then here you would have another 6. But the reason why this is difficult is because this diagram is going to become really complicated. So try and find a way of drawing your map, and then from that map you can see which branch would give you a good outcome. Well, anyway, do what you have to do. Press pause and have a go. Okay, so we're going, well, rolling 3 dice, we're going to imagine it as rolling 1 die at a time. So you could get, so you start here, you could get 1, 2, 3, 4, 5, 6. Okay, so 3, 4, 5, 6, and then so this here, this column here would represent our first die. Now we would then jump onto the second die. So we could get a 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6. Well, second die, we could get another 1, 2, 3, 4, 5, 6. Okay. Third die, 1, 2, 3, 4, 5, 6. And then fourth die, we could get 1, 2, 3, 4, 5, 6. And then the fifth die, we could get 1, 2, 3, 4, 5, 6. And then the sixth die, we could get 1, 2, 3, 4, 5, 6. All right. And then we would jump to our third die here. Now, third die, we could get 1, 2, 3, 4, 5, 6. Second one, 1, 2, 3, 4, 5, 6. And then jump to a third one, 1, 2, 3, 4, 5, 6. Fourth one, 1, 2, 3, 4, 5, 6. Fifth one, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And then we will then jump to the 2. Now this diagram here is really difficult. So let's just analyze the first branch here. Okay, so we are just going to look at this branch here. Okay, so yeah, once we've looked at this branch here, the number 2 branch will be exactly the same as the first one. So will be the third one. Well, anyway, let's look at the first branch for the time being. So we've thrown a 1 here. Okay, so let's have a look at this here. Hang on. So here, this is where we start here, and then we are just looking at the number 1 branch. So we've just thrown a 1 here. Okay, and then so this is our first die here, and then after the first die, we could get a 1, a 2, a 3 here, or a 4 here, a 5 here, or we could get a 6. So all these here represents our second die here. Okay, and once we've got a second die, we would then jump to a third die. So all the ones on the right here represents our third die. Okay, so basically we are just looking at this number 1 branch only. Okay, we are just looking at this number 1 branch only. So we could get a 1, a 1, and a 1. Well, we said that we defined this as not a good outcome. You could argue, yes, 1, 1, 1 is a double, but for our we basically define this as not a good outcome. Okay, so so this is not a good outcome. Now, a 1, and then a 2. So this is a good outcome because we've got So this is a bad outcome. So a 1, and a 2 is a good outcome. Okay, a 1, and a 3 is a good outcome. So 1, 1, 3 is a good outcome. And then 1, 1, and 4 is a good outcome. You see, but by you drawing a map, you can actually get an idea of what's going on. So first die 1, second die 1, and then a 4. Getting a 5 would be a good outcome. Of 6 would be a good outcome. So this here would be a good outcome as well. A 5, and then probability of a 1, 1, 6 is a good outcome. Okay. Now let's go back to the beginning. You start here. You get a 1, and then let's say you get a 2, and then you get a 1 again. So this is a good outcome here. So P of 1, 2, 1 is a good outcome because look, you've got a double here and a double here. Okay. And then you could get a 1, 2, 2. This is actually a good outcome. Probability 1, 2, 2. This is actually a good outcome because look, you got a double here. Okay, and then 1, 2, 3 would be bad. And then 1, 2, 4 would be bad. So basically, all these would be bad. And then you would jump to so let's go back to the beginning again. You're here. You get a 1 on your first die, and then you get a 3. So let me get rid of this here. So 1, 3, 1 would actually be a good outcome. 1, 3, 1 would be a good outcome because look, a double here and a double here. So a 1, 3, 2 would be a bad outcome. 1, 3, 3 is a good outcome. So probability of 1, 3, 3. This is actually a good outcome here. Okay, and then you follow it through. So hang on, 1, 3, 4 would be a bad outcome, bad outcome, bad outcome. Now you would go back to the beginning again. So you're here. You get a 1 on your first die here, and then you're going down the 4 route, and then 1 again. So this would be a good outcome. So P of 1, 4, 1 would be a good outcome. And then well, look at this diagram. A pattern emerges. So 1, 4, 4 would be a good outcome. And then 1, 1, 5, 1 would be a good outcome. And then 1, 1, 5, 5 would be a good outcome. You see, by you drawing a map, you get to see the pattern. So now we're going to go to the 6, 1, 6, 1 would be a good outcome. And then 1, 1, 6, 6 would be a good outcome. So So look, going back to our original thing, if we were to go to get a 1 on a first go, we've just in effect we have just in effect covered the whole branch here. So just by count the number of branches that leads us to a good outcome up here. So hang on. So this would be let's count these now. So 1. Remember, we're basically counting all the ticks here. Okay. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 good outcomes on our first branch. Remember, this is only for the first branch. So 15 good outcomes. So well, when you count these here, when you count the good outcomes here, it comes to 15. So let's look at this here. So going back to this one branch here, there were 15 good outcomes. Okay. But later we can just get this 15 and times 6, because we've got to go down the 2 routes, the 3 routes, and if you follow the same technique for number 2, it turns out to be 15 as well. And if you do the same with with the 3, going down the 3 route, it comes to 15 as well. 4, it comes to 15 as well. So later on we can times it by 6. But let's go back to the first branch now. Okay, let's go back to the first branch. So we are here, and then on the first die we get a 1, and we've just established that there are 15 good outcomes. Okay, so now looking at this here, the probability of going down. So you are here. You start here. The probability of you getting a 1 here would be 1 over 6. Okay. This is on our first die. So on your first die, when you roll it, the probability of you getting a 1 would be 1 over 6. Now you would jump to your second die. Now the probability of you getting a 1 here would be 1 over 6, and then the probability of you getting a 2 here would be 1 over 6. Okay, so my point here, the probability here of getting 1, 1, 1 here would be 1 over 6 times 1 over 6 times 1 over 6. So top times top times top, that comes to 1, and 36 times 6 would be well, 212 and 16, 216, and then now try and work out the probability of 113. So we need 1 here, which is a 6th, times a 6th here, and then times a 6th here, because when you're here, the probability of you getting a 3 would be a 6th. Okay, so again it would be 1 over 6 times 1 over 6 times 1 over 6. So basically it comes to this thing again. Okay. Yeah, if you do this bit, it's actually this. So now, well, I know that all these will actually be the same. Would be 1 over 6, 1 over 216. So, well, here it would be a 6th times a 6th times a 6th again. But basically, so we all these here represent branches that are good for us. So now we need, well, you need a 1, 1, 1, but so you need this branch here, or this branch, or this branch, or this branch, or this branch. Remember, if it's an or, you have to add. When it's an and, you have to times. So here you have to get this, add this, add this, add this. Basically, it's going to be this. 1 over 216 plus 1 over 216. Well, you're going to add it 15 times. Okay, but But rather than adding it 15 times, I'm just going to get this and then times it by 15. Okay, times 15. So when you times a fraction, it gets multiplied to the top. So this will be 15 over 2/1/6. So going back to this, to our original diagram here, suppose we've gone down the one route here. The probability of all the good outcomes for the first branch here, for the number one branch here, would be 15 over 2/1/6. Okay, and then don't forget you've got to go down the number 2 route, number 3 route, number 4 route. Well, this here represents all the good outcomes for number 1 branch. So now we just need to times it by 6. Okay, because there are, don't forget, we've just looked at the number 1 branch. We need to look at the number 2, 3, 4, 5, and 6. So basically, times it by 6. So this would be 90 over 2/1/6. So the probability of you getting a double would be 90 over 2/216. So if you jump to a calculator, can convert it to a decimal. Hang on, 90 over 2/1/6 equals. Hang on, it equals 0.42. So equals so probability of a double equals 0.44 what? 0.42. So the probability of you getting a double would be 0.42. So it's actually quite easy to it's quite easy to get a double. Okay.